Welcome. Thanks for joining us. It's a fantastic idea that you're here. Grab a notebook, pen, pencil, whatever you need to write with, basically. This is math from the void. Math coming at you out of nowhere. Today we're going to be doing a problem from the AP Calculus exam from 1991 on the AB exam. And here we have a function with a radical. This is a 3/2 power, so just notice that that's like a square root and then cubed. You could also consider the 1 plus tan x being cubed and then put in the square root. That's what we're looking at there. Okay, and so this domain is intended so that we have something reasonable in the square root that's not negative. Remember that tangent is a repetitive function. It repeats, and it does have some asymptotes, but this one's a little different. It's 1 plus tan x, and that's in the square root. Let's get started. Part A says, write an equation for the line tangent. I'm going to stop right there. I'm going to jot down the point slope formula. Y minus y value equals m times x minus x value, where the x value and the y value are the point where it's tangent, and m is the slope. This time they just gave us the x value. So we need to find the y value, and we need to find the slope. Let's go ahead and do that. The y value is not too hard. If we do f of 0, that's just going to be the square root of 1 plus tan of 0, and then cubed. Well, tan of 0 is 0, so this is just the square root of 1, which is 1, and then cubed, that is just equal to 1. So far we have y minus 1 equals the slope, we still don't know that yet, times x minus 0. It's going to just become x in a moment, but I'm putting it in the correct format so that it's clear where this is coming from. Now let's find the derivative, because we need the slope, which means we need the derivative. So we have to take the derivative of this function. It's a bit of a chain rule, but you'll be all right. So this 3/2 power is going to come down. We're going to have 3/2 1 plus tan x to the 1/2 power now. And then we're going to multiply by the derivative of the inside because the chain rule. So that would be secant squared. Okay, and where do we want to find this derivative? We want to find it at x equals 0. Very easy to do. So 3/2. Again, if we plug in 0, this is going to become the square root of 1 plus 0, which is just the square root of 1, which is just 1. And then secant of 0, since secant is just 1 over cosine of 0 is 1, that means secant is 1. And so secant squared is 1. So we just got a whole lot of 1s here. And that gives us a slope of 3/2. Now we can use that for our tangent line. And if you'd like, you can put it y minus 1 equals 3/2 x. If you really want to get it into slope-intercept form, go ahead. That's fine. I'm not going to stop you, but it could be in point-slope form. That's totally acceptable. Okay, part B. Good. It has us use the equation that we just found. So this question does not seem very hard. It wants us to approximate the value. How are we going to approximate that? Well, since we have a tangent line, we can use the graph at that tangent line. And so we have like some kind of curve. Do it in black. And so we have some kind of curve. We can use the information about this point here, or let's say at the 0, which is what we're doing, and we can use the slope there to say, okay, if we move down this line just a little bit, we're basically where the function is at. So we're using the tangent line to make an approximation. And we just use that exact equation. So it's going to be 3/2 times 0.02, because that's where we want to approximate it, and then plus 1. So divide this by 2, you get a 1. Multiply it by 3, you get a 3. So this is just going to be 1.03. We said that it's approximately. So let's write that a little bit more clearly. F of 0.02 is approximately 1.03. That's just basically using the equation of tangent line. Yeah. Now that's probably not the actual value, because the tangent line isn't perfect to fit the whole curve, but it's perfect at the exact spot of tangency, and we're not deviating that far. We're just going forward by 0.02. Okay, let's look at final question C. F inverse is the inverse of F. Okay, makes sense? Write an expression that gives F inverse for all x in the domain. Okay, well, yeah, you guys probably know the precalculus method for finding the inverse. We treat f of x like it's y, right? And the equation in this case is going to be 1 plus tan x to the 3/2 power. And the technique that a lot of people use is they switch the x and the y, basically. And then you solve for the y all over again. Technically, this new y that we're calling it y, it's the f inverse. And this is to the 3/2. But just to avoid having to write f inverse every time, we kind of just put a substitute y there. You can put anything there, honestly. So how do we unwind this? This is like a big knot. We have to unwind it layer by layer. So first we're going to do everything to the 2/3 power, and do this to the 2/3 power. So now we have x to the 2/3 power is 1 plus tangent of the inverse. I'll keep writing it just because I'm stubborn, but you can totally have it as a y or some other variable at this point. Okay, let's subtract 1, and then we're going to want to take a tan inverse of that. Tan inverse, that gets rid of the 1 and the tan, and there's our f inverse. So, I mean, if you wanted to, you could also just write like y equals f inverse equals tan inverse of x 2/3 minus 1. That one's really easy, guys. Really just have to know how to like isolate a variable and solve for a variable, even when there's a power and even when there's a trigonometric expression. Okay, so this is not a difficult one, guys. Definitely doable with no calculator. No calculator was required at all. I don't think I really calculated anything. I did here a tiny bit, but that's just barely anything. So yeah, hopefully you got through this one really quickly. When you get problems like this, sort of a breath of fresh air. You get to, double check your work, less pressed for time, so you can spend more time on the harder problems for the exam. And I will say that this is probably considered like an easy problem in an exam closer to the modern day. So from 1991, this is a while ago. They test a little bit more pre-calculus than you would expect here. Anyways, that's enough chatter for me. I'll see you guys next time in the void.